Hello everyone and welcome to today's video. In this video, we're going to be discussing RSpec matchers. Matchers are an extremely important concept to understand because using the correct matcher in a spec can make it much more readable and easier to understand. It's important that you have a basic grasp of some of the most commonly used matchers so you can choose the best one given your scenario for your certain specification. Let's jump into the computer and talk about some of the basic RSpec matchers that you'll be using every day while writing RSpec specs. Before we do a few examples of using RSpec matchers, let's do a brief overview of the matchers that are made available to us by RSpec. I'm on this Relish Apps documentation. This is RSpec documentation written in an end-to-end style, which makes it extremely easy to understand. The first matcher they mention in these docs is the EQ matcher. This matcher checks that two values are equal to each other. It uses the double equals method to do this. This method checks that the values are the same, but it does not require that the objects are the same. You'll see the difference when we talk about the B matcher. The B matcher uses the .equal method to check for equality. Actually ensures that the objects are the exact same objects, not just that they contain the same value. For example, if I had string A equal to A and string B also equal to the letter A, if I was to check if those were to be the same thing, I would get false because those are technically two separate strings, even though they contain the exact same values. If I just wanted to check that the values were the same and I didn't care that they're the same object, I would want to use the equal instead of the B matcher. We'll talk more about this in our example, and it will be clearer if you don't understand it, so don't worry about it. Some of the next matchers are comparison matchers. These are used with B, like the greater than or equal to, or less than or equal to matchers. There's also the nice be between, where you can specify a range of values and say that it's inclusive and your value must be inside that range. The match matcher is an extremely nice matcher for checking that strings conform to certain regular expressions, which you can provide in the parentheses right here. The be within matcher is very useful for floats. When you add two floats, multiply floats, divide floats, you can often get inexact values as the results. And so you can't compare them directly with an equals. You have to just ensure that it's correct up to a certain decimal place. That's where the be within matcher comes into play. We'll go over this in one of our examples as well. The start with and the end with matcher are also very nice to check that strings start or end with certain values. And finally, the be truthy and be falsy, as well as be nil, are great matchers to make your tests more readable and show that you're expecting the values to be any truthy value as opposed to just true, or any falsy value as opposed to false. The final matchers we're going to be talking about in this video are the matchers for errors. You can check that an error is raised. You don't care what type of error it is. You can pass in a class that you expect to have been raised, an error class that you expect to have been raised, and you can pass in a message that you expect the error to contain. These are some of the most basic and common matchers in RSpec. Let's do a few examples playing around with these different matchers. Okay, I've created a bare bones RSpec project that we can use to test out some of these matchers. If you're unfamiliar with how to start an RSpec project, please refer to one of my previous videos titled RSpec Tutorial Number 1, Getting Started. It shows you how to set up an RSpec project from scratch. All I have so far is just this rook spec.rb file. We're going to use TDD to implement some features of a chessboard and game, and we're going to do this with TDD as well as using the matchers we've been talking about. Let's first describe a rook. So we'll say describe rook do, and then we'll do a pending test and we'll say it returns the correct points value. A points value is each piece in a chess game has a points value. The rook's points value is 5, the pawn's points value is 1, and this just tells you how valuable a piece is. We'll make another example to test that rook returns the correct string representation of its name. it returns the correct name. Now, if we were to run both of these specs, we'll see that they're both pending. So our next step is to make them fail. We'll say do, and we'll instantiate a rook. And then we want to call rook.points and save that to a variable. Then we'll use one of our matchers. We'll say expect rook points dot to be, and we'll say 5. That's how many points a rook is worth. In our next example, we'll implement a body, and we'll say rook equals rook.new. We're going to cover how we can clean up some of this duplication in later videos. Then we'll say rook points equals rook.points. Excuse me, we'll do rook name. Rook name equals rook.name. And then we'll test expect rook name to be rook. We'll save that and run these tests. And you can see that we have 2 failing specs now. One of them says uninitialized constant rook, and the other says uninitialized constant rook. That's because we haven't defined the rook class in any of our files. So we'll go create a rook.rb file, and we'll create the rook class. We'll save that, and we'll run our specs again. Now we get an uninitialized constant rook. That's the same error we got last time, and that's just because we haven't imported our rook class into the spec file. So we'll say require rook and run the specs again. Now it says failure, undefined method points, and also undefined method name. That's perfect. Now we go and implement those methods on the rook class. We'll say def points, and all points is going to do is return the number 5. Let's run that, make sure it passes, and it does. So we get 1 passing spec and 1 failing spec. The failing spec is just saying undefined method name, so let's implement that. Def name, and we'll just have this return the string rook. So at this point, you might expect that both of our tests would pass. Let's run our tests and find out. As you can see, our test is still failing, even though it's returning rook, which if we look at our spec is exactly what we're expecting the rook name to be. The problem is we're using this B matcher. The B matcher is special. It uses the equals question mark method to compare the 2 values. What the equals question mark method does is it actually doesn't just compare the values, it compares that the objects are the exact same objects. It compares the objects' identities. What this means is that if 2 objects contain the exact same values, but they're different objects, meaning they have different object IDs, B is going to return false. Let's quickly show that strings have different object IDs, even if they contain the exact same value. So I'll go into the interactive Ruby console by doing IRB in my terminal, and I'll make a string called rook. Then I'll call the object underscore ID on it. And I can see it prints out 180. Now I'll create another string with the exact same content of rook and print out the object ID again. And it prints out 200. As you can see, these are different string objects, even though they have the same values. And that's why B is still failing here. In this case, we actually want to use the EQ operator, or equal. This uses double equals to compare the values, which doesn't take into account object identity, and instead just worries about the values of the strings. So if we save that and run our tests again, we should be able to see that they pass. And they do. This is a great distinction to make, and it's very important that you understand the difference between B and equal matchers. Next, let's talk about some comparison matchers. An example of a comparison matcher would be like this. We could say .2b greater than 5. This right here is the comparison. We're saying it's going to be greater than a certain number. Now let's use a few comparison matchers. We'll make a test that we can use a comparison matcher in. It returns a point value greater than a pawn's. So what we want to do with this spec is test that the point value returned from a rook is greater than a pawn's point value. This might seem a little redundant because we're already checking that the point value equals 5, but it's strictly just to show off the comparison matchers. We'll have a do block. We'll create another rook. And we'll get the points from the rook. Then we want to expect the rook points dot to be greater than 1. As I said, this test isn't very realistic, but it's just to show off the comparison matcher. After we run this, we should see 3 passing tests. Not only can you use greater than, but you can use greater than or equal, less than or equal, this will fail, and less than. The comparison matcher is a be between matcher. We can say expect rook points dot to be between, and then we give it a minimum value and a maximum value. We can run this and see that this also passes because 5 is in between 1 and 10. By default, this be between matcher uses a dot inclusive method. If we want to have this be exclusive, we can just write exclusive at the end. Now what would happen if we turned this 5 in the rook RB class into a 1? Because we're using the exclusive method right here, 1 is not included in the range, so this will fail. And it says we expected 1 to be between 1 and 10 exclusive, and it was not in between that range. Let's change that back to 5. Okay, another excellent matcher is a be within matcher. In order to test this, let's introduce a new spec file called RSpec. Let's require a class that we haven't created yet called player, and then let's go create that in the lib directory. We'll say class player, and we'll save. Now we're going to describe the player class. We want to use this be within matcher, so we need to think of some property of a player we can test that would produce decimal values. Let's say that players have credits that they can use to play chess games, and these can be fractional credits. So we'll say it calculates the correct credits remaining. At this point, we can run our specs and see that they're pending. We have one pending spec. We will now make this pending test fail. We'll do that by instantiating a player object. We will set the player's credits equal to 1.5. We'll then call a non-existent method called subCredits and pass in 1.3. We then expect the player's credits dot to be within 0.0001 of the value 0.19999. The reason we're using this be within matcher is because floating point values, when you subtract them, multiply them, add them, they're not exact. So you can't say that it's going to be equal to 0.2. You can't say that 1.5 minus 1.3 is going to be equal to 0.2 because it's not. It's actually going to be equal to a very large decimal value. We can see that if we open up an IRB console. We can see 1.5 minus 1.3 is actually equal to 0.199999999 and then a 6 at the end. So we don't really want to check that value, but we can check that our returned value is within 3 or 4 decimal places of the expected value. So that's what we're doing right here. We're expecting that our returned player credits is within 0.0001 of the expected value. Let's run our spec and watch it fail. Our spec fails, and that's because we don't have credits defined, and we also don't have that subcredits method defined. So first, let's fix the first error that RSpec is telling us about, which is saying we don't have a method credits. We'll go into the player and add an adder accessor for credits. Save that, run our specs again. Now it's telling us that there is no method called subcredits, so we'll go and add that, subcredits. We'll take in a subcreds, and it will just subtract that from our credits. Credits minus subcreds. We'll save that and run our specs, and they should pass, which they do. As you can see, the be within matcher is very powerful and should often be used when comparing floating point values. We now want to do an example of a be truthy matcher. In order to do this, let's introduce another spec that tells us whether a player is active or not. It returns the correct value for the player's active status. We'll then give it a do block so it fails. We'll create a new player. And we'll say the player's active status equals yes. Then we'll expect the player.active.toBeTruthy. The reason we use the be truthy in this case is because the active status is a string and not the literal value true. This is much more dynamic and it will return true for any truthy value. Let's run these specs and watch them fail. As you can see, it fails because we have no active equals method. Let's go provide that in the player class. Save that, and we'll run our specs again. And they pass. That's because this yes value is truthy. We can also use the value 0 because that's truthy in Ruby, and it will also pass. The be falsy matcher is exactly the same, except for it will return true for any falsy values. The only falsy values in Ruby are literally the word false and nil. Finally, we want to test out the raise error matcher. Let's do that by defining another spec in this player spec file. Returns an error when subcredits is passed a 0 credit value. We'll give it a do block so it fails, and we'll say player equals player.new. We'll set the player's credits equal to 2. We'll now say we expect, and you can actually pass a block to expect. We expect player.subcredits. If we pass in 0, we expect that to raise exception, and we have to describe what type of exception we want it to raise. For now, we'll just say standard error. We'll run those tests and see if it fails. We can read the error message, and it tells us that we expected player.subcredit0 to raise an exception, but nothing was raised. So now we can go into the player.rb file. We'll say that if our subcredits receives a 0 value for subcreds, then we want to make it raise an exception. So we'll say raise standard error. After we run our tests again, they should pass. This is an example of how to use the raise exception matcher. Thanks for watching this video. Hopefully you learned something about RSpec matchers and you got some context about when you want to use certain matchers over others. I hope that you now understand the difference between the be matcher and the EQ matcher. You understand why the be within matcher is great for using with floating point values and how to expect that exceptions will be raised in your methods. If you enjoyed this video, please subscribe and like the video. I'm going to be releasing more RSpec tutorial videos as well as videos on Ruby and the Go programming language, which I also quite enjoy. Please subscribe if you haven't already. Thanks again for watching, and I hope you have a great rest of your day.